All right, hello everybody. So I just want to do a quick walkthrough of some things you can do with the data you pull off your LabQuest and Jump to maybe streamline presenting your data here. This is a qualitative lab report for the amino acid titration, but making nice graphs will make it much easier to do. So here I have the data our TAs collected at TA training. Um, I've relabeled some of these unknown X and Y so as not to spoil them. I don't really remember who got what anyways. But basically, I want to take this data, I want to put it into Jump, and I want to make the graphs that we will put into our final post lab. And some of you may have made this during lab already, and if so, great. If not, well, here's how to do it. We're going to use something called stacking to take all these data and put it into convenient columns for us. So first, I just want to get all this data on my clipboard, highlight it all, edit, copy. I like to drag along the top here. Going to go into Jump, going to make a new data table. Bam. I like to click this top column heading to select it, then edit paste with column names. This is absolutely essential. If you do this, your data will input properly as continuous data and Jump will auto detect the format. If you do this wrong and you do edit just plain paste, it'll put the column heading in this first row here, which will make all of this character data, and then you have to go manually reformat it. All right, so I have my data here. Notice conveniently the LabQuest puts out volume run, volume run, volume run, volume run. I'm going to take this, I'm going to go to table, stack, and I'm just going to highlight all of my columns. And because they're stacked up every other one, I'm going to go to this multiple series stack, tell it I have 2 series I want to stack. They're not contiguous, they're just every other one. And I'm going to stack them like this. You can play with these labels if you want, but it doesn't do a whole lot. And that'll give me this. So now I have labeled data, labeled data. This data is my volume, and I can also check that because these look like volume measurements. But volume, milliliter here. This data is my pH. Does not have a unit. And then I have these extra rows here, which I am going to use. So I'm going to use these to recode our data. So I go back to my original key sheet here. I have a key here as to what these mean. I'm just going to do right click, recode, new column. I'm going to call this sample. Then run 1 is proline, run 2 is histidine. Run 3 is unknown X. Run 4 is glutamic acid. Lysine unknown Y. All right, then recode that. Now I have a new column. I'm going to get rid of these 2 columns here. And now I have a set of basically pseudo X coordinates, my Y coordinates, and identifiers for them. Now in our whatever the heck it's called, post lab instructions, we ask for you to plot pH versus moles of OH minus added. So we want to convert this volume of titrant to moles of titrant. Since we're given the molarity of this, it isn't that bad. We just have to convert from volume of solution to moles of solution, which is exactly what molarity is for. So I'm just going to pull that up real quick. And that would be, if I have milliliters, I want to convert this into liters probably. To, we've got 1 liter per 1,000 milliliters. And then our concentration was 0.05 moles of NaOH or OH minus per liter. So I just have to take my value, divide it by 1,000, and then multiply it by 0.05. So we'll do that in Jump. We'll make a new column here. We'll call this mole OH minus added. Don't worry that making this into a superscript is incredibly difficult. We're not going to worry about it. Formula to make this a formula column, and then I'm just going to take my volume. I'm going to divide it by, I hit my divide key on my keyboard. You can also click this, so let's try that. Divide by 1000, and then click this to make sure the whole box is selected, and I'm going to multiply that by 0.05. All right. And this has the mole included in it, so I don't need to like reorganize this as like OH minus added with mole afterwards. I could, whatever, they're the same thing. All right, so let's make our first graph. So we're going to take our pH here, going to put that on the y-axis. We're going to put moles down here. We're going to overlay by sample, and we're going to turn these into line graphs. All right, great. So one thing you should notice is that all these kind of start around the same pH coordinate, and that's because ideally we use the HCl to start at the same pH each time. Depending on your actual starting point, your graphs might align up and down a little bit oddly, and that's okay. If you want to, you could subtract out a bunch of data and shift these all over, but that's a lot of work for not a lot of return. I'm really just looking at what are the shapes of these. All right, so here I have more data than you have. You probably won't have lysine on here, so here we can hide that. And you probably only have one unknown on here, so we're going to hide that. Bam. So this is probably more what your graph will look like. You do not need to have all the way down to 0 there. All right, beautiful. So these two look like the same curve. That's probably what this unknown is, whatever. All right, graph 1, done. And then another trick is you can shrink these in JMP and then export them. So if I gonna turn off a bunch of options. If you hold the Alt key on Windows or the one of those four keys in the bottom left on Mac, I think this option. I'm gonna say option and click the arrow. It'll bring up all the options at once. So I'm gonna turn off the title, the footer. All right, bam. You can just edit, copy, and then paste these. You don't always have to export them. If you shrink them before you export them, so like notice that I shrank it, comes out like that. If I make this really big and then export it, comes out really big over there, but the axis changes. So then if I want to make it the same size, suddenly, I have to shrink it down, which makes everything smaller. So really recommend shrinking things before you export them in JMP. All right. So this is one of the graphs we asked for. And this graph, not too bad to make. Now this next set of graphs we asked for is, okay, we want this, but one for each graph with the little pKa's noted on there. So I'm going to show one of these. I am going to show quickly why we can't just wrap them, which would be super nice. But if I put a line on this, it applies it to all of them, which is why we're not going to do that. All right. So let's get rid of this. Not. All right. Yeah, let's do it. Okay. We've got a couple options on how I want to do this, and we're doing it live. All right. So let's say I want to do proline first. I'm going to select all of my not proline and just exclude them all from the analysis right now. Bam. So now I have a graph that's just proline. I want to put on this graph the pKa's. So in your thing, your post lab instructions, you have a hyperlink to this Vanderbilt page with the pKa's on it. I'm just going to look at proline. We've got 1.95 and 10.64. So I'm just going to double click this here to bring up the axis instructions. I'm going to add pKa's at that. So I've got 1.95. I'm going to label this 1.95. That'll put a label on the side, I think. And then 10.64, again 10.64, add. Beautiful. And we can see here that we did not go low enough to hit that pKa. That's fine. We tested that in TA training, and it makes your life way more difficult, so it's not worth it. All right, and then here's one graph. So file, export, probably want to shrink this down a little bit so that it's legible when you put it in your final product. And then it's really not too bad. So we're going to go back to here and do our next one. So we're going to select all of the proline. We're going to exclude them all. And then maybe we'll do histidine next. So we'll uh, unexclude that. Bam, that pops up. We're going to go in here. Just going to get rid of these guys. We've got, oh gosh, okay, give me a second. Hide that. All right, so the histidine values are 1.8. Add, we've got 9.33. Add, and we've got 6.04. Add. All right, there we go. And oh, look at that. We've got some what looks like a little buffery region there. All right, and we can't see down that one. That's okay. That one's a little hard for us to detect just because of the fact that we used like 0 pH HCl to adjust this. So it takes a long time to get there if we want to. And then we're using 0.05 molar NaOH to get back. So if we add like, 10 drops of HCl, we need theoretically 200 equivalent size drops of your titrant to get back because our titrant is 20 times less concentrated than our acid that we're using. In reality, it's even worse than that because the drops from the burette are way smaller than the drops from the dropper by like a factor of 3. So you would need like 600 times more titrant to undo starting at 1.7 instead of starting at 2.7. And we don't think that makes this take like twice as long. All right. The other thing I didn't ask, but it probably would have been a good question is, why does this taper off at the top here? There's no buffering happening here. This is actually just we're getting close to the pH of the titrant. And if you remember that log scale, like between log 10 and log 11, that's a tenfold change in titration or pH, OH minus H plus concentration. So going from 10 to 11 is fine. Our titrant is around pH 12 something. So going from 11 to 12 suddenly gets into the magnitude of our titrant, and it's very hard to titrate up to our titrant. We would have to completely dilute our sample with titrant, which we can't do. All right. So do that a couple more times, export these, slap them into a single composite figure, A, B, C, D kind of thing. I guess ABC because you probably didn't do lysine. And that'll be that. So thank you for this wonderful jump tutorial with Dr. Moore, Jordan, the big J. Don't call me that. I'm just kidding. You can call me that. And hopefully we'll see you after spring break or in lab on Wednesday. We'll see.